This lesson is on the slope-intercept form for the equation of a line. You definitely want to be familiar with the slope-intercept form for the equation of the line, as it is, I think, the most useful form because you can quickly graph a line given its when its equation is in the slope-intercept form. So the slope-intercept form is y equals mx plus b. Please do memorize that. Even if that's on your formula sheet, it is very useful to memorize. So m is the slope of the line, which we looked at in our previous lesson. B is the y-intercept of the line. I'll show you what that is soon. X is the independent variable that's graphed on the x-axis. Y is the dependent variable since it's dependent on x. So when we fill out this equation, y and x stay as y and x, and then we put in numbers for m and b, and then that will represent graphically a line. So any point on that line, you can put in a value of x from that point, and then it'll give you the value of y for that point. This is the easiest form to work with, as I mentioned, for the equation of a line. You will learn about two other forms in subsequent lessons. What is the equation of this graph in slope-intercept form? So we have a line over here on this graph. So we want it in slope-intercept form. The first thing you want to do is write your slope-intercept form with just the variables. We just need to figure out m and b and plug those into that equation, and then you're done. You've given the equation of that graph then. So m is the slope, which is 5 over 7. So there I've figured out what the slope is. Now, when you want to find the slope, you mainly need to make sure that you pick endpoints. You can pick endpoints anywhere along this line, except they need to be somewhere where you know that line intersects an intersection of grid lines, so that you're sure that it goes up exactly 5. If I pick this point, say it's 5.7, you don't know exactly where that is. So pick two endpoints anywhere along the line. You can see I know that this is one of the endpoints and this is one of the endpoints here. And so our rise is positive 5, our run is positive 7. So our slope is rise over run, 5 divided by 7. B is the y-intercept, which is literally where the line intercepts the y-axis. So this is our line. Where does it intersect the y-axis? Right there. And so our y-intercept is the y value where it intersects the y-axis, so it is positive 2 for this line. So now we just plug m and b into the equation. So 5 over 7 is our slope, our m, and positive 2 is our b, and this is our complete equation now. So now you can plug in a 0 for x and you'll get a 2 for y, so that's this point, 0, 2 in brackets. Say I wanted to know this point over here. That would be a negative 7 for x. And then you can see you put a negative 7 for x, that'll cancel with the 7 on the bottom, but you're left with a negative times the 5, so that's negative 5 plus 2 is negative 3. And as you can see, that's what we have here. This point is negative 7 for x and negative 3 on the y-axis. So you write it as bracket negative 7, comma, negative 3 bracket. What's the equation of this graph in slope-intercept form? So let's write our form there. We just need to figure out m and b again. M is the slope, which is negative 8 over 2, which just equals negative 4. So again, you see I know that point intersects on the line, and this point does. I don't know exactly what that point. I could have picked this point. That would have been just fine. You would have seen then it would have been negative 4, positive 1. Negative 4 over 1 is just negative 4, so you would have gotten the same thing. You could have picked, say, that point and that point. So as long as there are 2 points that you know for sure, are on the line and they intersect a grid point, you'll get the correct slope. So, and it's typically easier or best to pick a bigger triangle. You don't have to, but that's typically what you want to do. So -8 divided by +2, that's our rise. So going from left to right, rise is actually going down, so that's -8, and then left to right, our run is +2. And so that's our slope, -4. B is the y-intercept, again, which is literally where the line intersects the y-axis. So it is a what? Y equals -1. So let's plug m and b into the equation. Y equals -4 is our slope, m, and b is -1. So that is your complete equation for this line shown in red here. The lines we've looked at in this lesson are functions. Below is the equation from the previous slide, and its graph to the right there. As a review, a function relates two variables. For a given value of x, there is a corresponding value of y, and only one corresponding value of y. If x equals +1, then the corresponding y equals -5. This is shown graphically by the point 1, -5. So I alluded to this earlier, and I'm just showing it here now more clearly. So this is +1. This is the x-axis here. The horizontal axis is the x-axis. The vertical axis is the y-axis. So all of this down here below the x-axis are negative y values. All above the x-axis are positive y values. All to the right of the y-axis are positive x values. All to the left of the y-axis are negative x values. So down here we have a +1 as our x value and a -5 as our y value. And this line again is shown here in slope-intercept form. If we plug in a 1 for our value of x, we get -4 times 1, which is -4, minus 1 is a -5. So y equals -5 is our corresponding value to x equals 1. And so you can pick any point on this line, and that'll work out the same in this equation here. An easy one here, x equals 0. You put 0 in for x, that term goes away, and you're just left with y is -1. So another point, of course, is the y-intercept, 0, -1. So graph this equation, y equals 2x minus 3. As I mentioned earlier, it's very quick to graph an equation that is in slope-intercept form. Start at your starting point of the y-intercept, 0, -3. From there, use your slope of 2, which is just 2 divided by 1. If you rise over run, you want rise of a 2, +2, and a run of a +1. Remember, 2 is just 2 divided by 1. If it helps you out, if you just see a number there like that, you can put a fraction and put a 1 underneath to make it clear to yourself that rise is 2, run is +1. So now we have our starting point. We have started our line by putting in our slope, and that's actually all you need. And now we can complete our line, because for this to be an entire line now, we just add on the left and right parts of it. So this is why slope-intercept form is so useful. To show you again, you have a starting point, you have 1 point on the line. As soon as you have 1 point and you have the slope, you've started forming the line, and then you just extend it, and you're done. It is very fast. So let's look at another one. Y equals -3/4 times x plus 1. Again, our starting point, use your y-intercept. You already know 1 point on the line. And then using our slope of -3 divided by 4, our rise is -3, so that's 3 going down. Our run is +4, so 4 going to the right. And now we've started our line. And now, of course, you just need to extend it on both sides, and you're done. Write two equations of lines parallel to the below equation, y equals 2/3 x plus 4. If other lines share the same slope as the original line, then they will be parallel. What is the slope of the given line? It is 2 divided by 3. The slope of a line parallel is thus 2/3 as well. It doesn't matter what the y-intercept is of our two example lines. It just needs to be different than the original line, or it would be the exact same line. That is, the equation will not change at all. So example 1 of a line parallel to the original line, y equals 2/3 x. Remember, you need to keep your slope the same, and then just pick a different y-intercept. So you're shifting it down in this case by 1. All of the y values in the compared to here, you basically shifted them down by 1. And example 2 of a line parallel to the original line. So again, most important, keep the slope the same. And then I've just shifted it down further. I've picked a y-intercept of -2. So now how much have I shifted down compared to this one? We've gone from 4 to -2. We've shifted 6 down. Write two equations of lines perpendicular to the below equation. So now we need two lines perpendicular to the below equation. The below equation is y equals -5/3 x plus 2. Remember that the slope of a line perpendicular to the slope of another line is the negative reciprocal of the other line. If line A has a slope of -7/2, then line B has a slope perpendicular to line A if its slope is +2/7. So remember, you take the reciprocal of this, which is 2/7, and then you change the sign to a positive. So what is the slope of the given line? It is, right here, -5/3. The slope of a line perpendicular is thus the negative reciprocal of this, so it'll be 3/5, and then switch your sign to a positive. It doesn't matter what the y-intercept is of our two example lines. They could even be the same y-intercept as the given line. Since the slopes are different, they will be a different line already. So example 1 of a line perpendicular to the original line, y equals 3/5 x plus 2. The main thing here again is we need to use that negative reciprocal of our original slope. And then you can pick any y-intercept you want. So I picked the same one to start with. So if you can imagine those two lines, one is having a negative slope here, and so if you're walking left to right, you're going downhill, and it's going through that y-intercept of 2. And now I've drawn a line that has a positive slope that's perpendicular to this line, and it's going through that same y-intercept. Example 2 of a line perpendicular to the original line. So again, the main thing you need to do is use the negative reciprocal of the original slope, so 3/5 x, that's done, and then just pick a different y-intercept, and then you formed a different line than your example 1. And our lesson is over.